Hi everybody, today I'm going to try my best to explain some parts of Task 2 in the May-June 2021 pre-release material for Paper 4 in Cambridge's 9608 Computer Science syllabus. Okay, so it's about a binary tree, and here's an example of a binary tree, and we're just going to shoot down and we're going to look at Task 2.3. This is where we're going to start in this video. Write a program code to store the binary tree as a 1D array of records. To just simplify this a little bit, I'm just going to ignore Task 2.2. I'm not going to put these items into the tree. Let's keep the tree just like this. Okay. Write program code to store the binary tree as a 1D array of records. Each record should contain a pointer to the node to its left, the pointer to the node on its right, and its data. And we're going to store that tree in an array. Okay, so first of all, how can we store this tree in an array? Well, this is my technique. It's a classic technique for putting this kind of visualization into an array. Start at the top and go down, working from left to right. So the first element in the array will be this node, then there'll be this one, then this one, then this one, this one, this one, this one, and then this one, and finally this one. Okay, so ultimately we're going to end up with an array storing nodes like this. Okay, maroon, black, silver, amber, indigo, red, violet, grey, and lime green. Maroon, of course, being the first node at index 0. Okay. Of course, we also have to define a structure for this. It's really an abstract data type, and in Python I'm going to create a class called node. So let's jump into a bit of Python programming. In fact, I've already created my node class. Every time I construct a node object, I'm going to send it a left pointer value, a right pointer value, and some data. I've also got some accessor methods here and some mutator methods here because I might want to update the pointers, and I've also created a method called toString which prints out all of the attributes of the object just as one line: the data, the left pointer value, and the right pointer value. Okay, so that's quite a useful method in my class. Now what I need to do is construct some nodes. So that's what I'm doing here. So our first node, the one at index 0, was maroon. And do you remember that, or let's go back to here. Maroon's left pointer points to black and maroon's right pointer points to silver. So according to my design here, maroon's left pointer will be 1 and maroon's right pointer will be silver. Okay, so that's the code that I've got here. Left pointer, right pointer, data. That's the first node. The next node has a data item of black, and again, if we quickly go back and have a look, black's left pointer goes to amber and its right pointer goes to indigo. So if we look at my design, black's left pointer goes to 3 and the right pointer goes to indigo, which is 4. So 3 and 4 are the two node pointer values for this node. So you just need to work your way through that so that you can get all of the data for the nodes. You can quickly see that some of the nodes are leaf nodes. They don't have any children. They don't have any pointers to other nodes. So for example, the amber node, there's amber, doesn't have any pointers. So I've just set them to be none. Okay. Now, what I'm going to do is push all of those individual nodes into a node array, which I'm going to call nodes. So N0 is the first one, N1, N2, N3, N4, N5, N6, N7, and N8. What I'm also going to do in this array is include a few extra elements which don't reference any node objects, so that later we can insert some more. Brilliant. Okay. So you've got that idea of a free pointer, right? So our free pointer in this scenario would point to this node here, whatever this index is here. I think it's index 9. That would be our free pointer to help us put a new node into there. All right, just to see what's going on, let's do for x in the array, in nodes, let's call my toString method that I designed in the node class. And let's run this and just see what happens. Okay, so it prints out all of the data for each of the nodes. Left pointer, right pointer, left pointer, right pointer, left pointer, right pointer, leaf node, left pointer, etc. Oh, we do get an error, of course, because in my array we have some nones. So none.toString doesn't exist. That's an error. So let's just tidy up my code a bit. If x doesn't equal none, then that means we have an object and we can print out some data. So take a moment to think about what I've just done there and review this video so far if you don't understand what I've just done. Okay, stop, rewind, just watch it again. Right now we are going to move on to... In fact, I'm not going to move on. Just going to leave it there for now, and I'm going to create another video to help us move on. Okay, this is just a short video showing you how to set up your node array.